Hello and welcome. In this video, we will talk about how data is displayed in different formats. When a researcher conducts a scientific study, they then want to eventually publish it in a journal. The researcher will then show the data to the readers in various forms. And these results will then represent what the study has found. In this video, we will discuss a few of these methods, including the forest plot. This is not a complete list of figures and methods used to display data. There are hundreds of other ways, but we will speak of the more common ones. One of the very common way to display data is in the form of a table. This is very effective to present information clearly and concisely. The data that you can present in a table can be very simple or it can be very complex, and there are some techniques in which you can do that. So the first thing about the title is to read the caption or the title. If you read the title carefully, this will tell you about the data in the table. At times, the title will also contain alphabet N at the end of the text. This N will mean the population under study, or it will also mean the population for which the data has been analyzed in that particular table. We then come to column and row headings. So the data comprises of columns and rows depending upon what you want to display. Sometimes the author will make borders and grid lines, but it is not necessary that every table will have a border and a grid line. There may be some abbreviations used in the table because you have to fit in the text into a narrow column. But then if you do that, then at the bottom of the table, the full word of the abbreviation will be provided. And that word will be marked so that you know what the abbreviation stands for. There may also be some footnotes or notes which contain information about the abbreviations or provide additional context or clarify any unusual data points. Use subscript numbers to link data in the table to corresponding notes. An example of clarification of any unusual data points is that at times in one row, a different number of the population may be used. And so then it will be marked that in this particular row, the population number is different to the rest of the table. So here we come to a table. And supposing if this table is presented to you and you are asked to comment on this table, then you will do it by the following way. So first of all, you will read the title and you will say facilitating factors and barriers for effective clinical audit. So the author is trying to tell us what are the different factors which can facilitate, and what are the barriers that can form obstacles for doing an audit which is effective in making a change. So an effective clinical audit means an audit which is going to make some kind of difference. So the author has given us rows, 1, 2, 3, 4, 5, 6, 7 rows. And the author has also given us 2 columns. So this is the first column, facilitating factors, and this is the second column, obstacles. And in the first column, the author is telling us that clarity of design and data collection is an important factor that facilitates an effective clinical audit, good planning, organizational support. That means that if you're working in an organization or an institution, that somebody very senior at the highest possible level is supporting you, dedicated staff who are doing the audit, and collective analysis of the results. So these are all facilitating factors. And then if you look at the opposite side, which is the obstacles or the difficulties or the barriers which will not allow you to have an effective clinical audit, then these are also very clearly written. No clear objectives, lack of resource, lack of clarity, lack of organizational support and if people are unwilling to change. Now, this is a more complex table that you can see over here. So for the sake of not violating copyrights, I have deleted some parts of this table, but let us just go into it one by one. So first of all, we go to the title or the caption, and as you can see here, that the title is saying that laboratory and clinical features in patients with epilepsy treated with AEDS. So because I have read the study, so I know that this AEDS stands for anti-epileptic drugs. So the authors want to see laboratory and clinical features in patients with epilepsy treated with anti-epileptic drugs. And this study is actually a meta-analysis. How do we know it is a meta-analysis? Because on the left-hand side in this column here, a number of studies have been mentioned. So one study was done in 1997, sorry. Then one was done in 1998, going on, and then there was one done. The most recent one was done in 2010. So this is probably a meta-analysis because they are doing a comparison about results from different studies which were conducted over a long period of time from 1997 to 2010. That means 13 years. Because this is telling you the oldest study and this is the most recent study. So in the first column is AED, that means anti-epileptic drug. So this is the row. So first of all, we'll go to the first row, anti-epileptic drug, the study and the different studies, then T. Now T stands for testosterone. SHBG. SHBG stands for sex hormone binding globulin. Even if you think that you know this abbreviation and that you don't need to look it up, but always look it up because sometimes an abbreviation can stand for two separate topics. FAI stands for free androgen index. A stands for androstenedione. DHEAS stands for dehydroepiandrosterone sulfate, and E2 stands for estradiol. And then there is some other data. So this is the first row, which is telling us the headers of each column. So in this particular table, what the author has done is that they have looked at two drugs. They have looked at PB, which stands for let's see what it stands for here. PV stands for phenobarbital, and PHT, which stands for phenytoin. So they have studied two drugs, phenobarbital and phenytoin. So I've actually collapsed this table, so you think that there is fewer studies in the phenobarbital drug and more in the phenytoin, but actually in the table, the table is a very long table and it has got a huge number of studies for the phenobarb as well as for the phenytoin drugs. So when we come, so now we are trying to understand what this table is saying, and this is what will be expected of you if somebody shows you the table and they says to you that what is this table telling you? So first of all, this table is about laboratory and clinical features in patients with epilepsy treated with anti-epileptic drugs. And in this table, the authors have tried to see that they have taken a number of studies, and in those studies, because it's a meta-analysis, they have taken two drugs only, phenobarbital and phenytoin, and they have tried to see that if these drugs are used in patients with epilepsy, what difference does it make to the hormonal levels in their body? And they are checking upon testosterone, sex hormone binding globulin, free androgen index, androstenedione, dehydroepiandrostenedione, and estradiol. So once you have grasped this basic understanding of the table, you're almost 50% there in your answer and in your satisfying the person who has asked you the question. So as you can see that this little symbol here is an equal sign with which means slashed, and this means unchanged, and this sign means increase, and this sign means decrease. Okay, so these are the 4 symbols that I use to show that if this drug is showing an increase or it's showing a decrease. And plus, there is also a word called NA, and NA means not available. In other words, in this particular study that was done in 1997, testosterone showed that testosterone levels were not changed after the taking the drug phenobarbital. The sex hormone binding globulin levels were unchanged. The free androgen index was unchanged. The androstenedione levels were not available in the study results. The authors had not studied it. The dehydroepiandrosterone levels were not available and they were not studied. And the estradiol levels were decreased slightly. So this is an important finding in this particular study. Similarly, if you go through line by line, you can then understand that what are the different ways in which the results have been made available. So other data, in some of the studies they have shown, but you cannot interpret this data very clearly in this table because I have actually reduced the size of this table to avoid any copyright infringement. And so this table has been changed slightly so that it does not infringe on the copyright, the right of the authors. So again, I will repeat again that if this table is shown to you in any kind of a situation and somebody says to you that please have a look at this table and interpret the results, then you can say that this table is showing the laboratory and the clinical features in patients who have epilepsy and who are being treated with anti-epileptic drugs. In this particular table, the researcher has shown us only 2 different kinds of drugs, for example, phenobarbital and phenytoin, and they have shown studies which were done on these drugs in epileptic patients, and they have also shown us that what was the level of effect on testosterone levels in the patient, sex hormone binding globulin levels, free androgen index, androstenedione, dehydroepiandrostenedione, and estradiol. And this study is actually telling us that this is a meta-analysis because they are comparing studies and not individual patients. When you compare individual patients, then it is never a meta-analysis, but when you have studies, then it is a meta-analysis. So we cannot conclude anything from the basis of this table, but this table is giving us some data. So what it is showing us is that phenytoin seems to have the maximum effect. In a number of studies have shown that it tends to increase testosterone level, and to some extent the sex hormone binding globulin level, to some extent the free androgen index, and to some extent the androgen levels, and to some extent the dehydroepiandrosterone levels, but it has no effect upon estradiol levels. So that's just a general impression that you get from this table because a number of studies, the results have not been available for a number of the hormone levels, and in a number of studies it has been unchanged. So this symbol stands for unchanged. So I hope that this gives you an idea about how to read a table. When the data is being displayed in the form of a table by the researcher, how will you read it? Okay, let's move on to another method of display. Now these are pie charts. So pie charts are often used to show the composition of a whole, such as the distribution of different categories or percentages. So if you create a pie chart in a visual way, it represents data in a circular format. It's actually a very simple method of displaying data because it cannot be very complex. The data cannot be presented in a very complex way if you want to present it as a pie chart. The pie chart can only give you just a basic distribution of the data display. So just as a pie, which is like a cake, and it is cut into slices, so just as a pie is cut into slices, each slice or sector of the pie will represent a portion of the whole. Pie charts are most effective when used to represent data with a relatively small number of categories. So for example, male, female, 2 categories, or male, female, children, 3 categories, or male, female, children, infants, newborns, 5 categories. Or you can have data from Sindh, Punjab, Gilgit-Baltistan, NWFP, or Balochistan, and that's about like 5 categories. For more complex data, or when you have large number of categories, then you will use other kinds of charts, for example, bar charts. This data is presented as either a percentage or as a proportion. So because you have a pie, so that means the pie now has to be a whole. And the whole can either be 100%, 100 if you are going to present the slices as percentages, or the whole can be the total number of patients or the total number of items that you have studied. And you can say that out of, supposing if you have 154, then out of that 54 had this characteristics, and 25 had this characteristic, and 23 had, so you just combine, but then the whole should add up to 154, which is your total number of patients. So, and then of course, then you can, often pie charts are customized with colors, with labels, with, and with the slices may be different colors, etc. Now let's imagine a scenario where this pie chart is presented to you and you are asked to explain what this pie chart is telling you. So out of interest, I'm just informing you that this pie chart has been taken from the Pakistan Demographic Health Survey 2020. So first of all, as we did in the table, we will read the title. The title says fertility planning status. In other words, if a woman is planning her fertility, then we are going to show the percent distribution of births to women age 15 to 49 in the 5 years before the survey, including current pregnancies, by planning status of births. So in other words, the researchers looked at different ages of women and they tried to see that did they want to plan a pregnancy or did they not want to plan a pregnancy? If the pregnancy had happened, was it unwanted, was it mistimed, or was it wanted? So these are the 3 categories in which they have distributed the data: unwanted, mistimed, or wanted. So unwanted means they did not want the pregnancy, they did not plan the pregnancy, but the pregnancy happened. Mistimed means they did want the pregnancy, but perhaps it happened earlier than what they had planned. And wanted means that they had wanted to become pregnant, but they did become pregnant when they wanted to. So this is a very simple data where the larger portion, the blue portion, are the women who wanted the pregnancy and had the pregnancy when they wanted it. So this is 88%. Only 5% did not want the pregnancy, and about 7% wanted the pregnancy, but they didn't want it very early, and they actually happened to become pregnant even before they wanted to. So this is a very simple data explanation. Bar chart. A bar chart is usually used to present either simple data or a complex data. If somebody gives you a bar chart to read, then first of all you read the title. The title will tell you the context and will also describe what the chart is showing. And it is usually placed above the chart, or sometimes it can even be below the chart. The bars themselves are the rectangular or the vertical columns that rise from the x-axis to the level corresponding to the value on the y-axis. The length or height of the bars represents the magnitude of the data for each category. And the values on the y-axis will represent the values or measurements associated with each category. These values are usually numeric and can represent quantities, percentages, frequencies, or any other relevant measure. The axis labels are both the x-axis and the y-axis. They have labels to indicate what they represent. The x-axis labels identify the categories or the groups, while the y-axis labels specify the scale or the units of the measurements. The categories or the groups are the horizontal axis represents the categories or groups being compared. These categories are typically discrete and non-numeric, such as months, products, or regions. And the legend is optional. If the bar chart displays data from multiple series or data sets, a legend may be included to clarify the colors or patterns used for each series. There may be some grid lines or they may not be grid lines. This is optional. And the vertical bar chart or the column chart is a vertical bar chart. The bars are oriented vertically along the x-axis. Sometimes the bar chart is placed horizontally, and then you can just see that in the horizontal way you can see the chart. So it can be either a vertical bar chart or it can be a horizontal bar chart. There are many different types of bar charts. There can be a grouped bar chart. In this, what you see is that there may be 2 or 3 or 4 bars which are grouped together, and then a second one where those 3 or 4 are grouped together. A stacked bar chart is when you have a vertical bar, and in that bar you have some divisions and you have different data sets. A clustered bar chart, in which is a combination of grouped and stacked bar chart, or a normalized bar chart in which the data is presented as a percentage. So let's look at this chart and try to understand it in the light of what we have learned in the previous 4 slides. So here the title is given at the top of the bars, and the title is Trends in Wanted and Actual Fertility. In other words, if a woman wanted to become pregnant and if she did become pregnant, then what are the trends in terms of the number of women who do become pregnant and the number of women who don't become pregnant. So this is in this slide they have written the wanted and actual number. So these numbers 4.9, 0.6, 4.3 is representing the actual number of children which a woman wanted. So the bars themselves are rectangular. As you can see, this is a rectangle, this is a rectangle, this is a rectangle, and this is a rectangle. And they are arising from the x-axis to the level corresponding to the value on the y-axis. So for example, this is the x-axis. So they are arising from the x-axis and they are corresponding to the value on the y-axis. So over here is the y-axis, and this is the y-axis, and this is the x-axis. So they are arising from the x-axis and they are actually going up in value as compared to the values on the y-axis. So the y-axis has got some values. For example, this point is 0 point where the line will start, and then it will go up after every one number. And so, for example, this is up till 4. So anything below 4 is here 3.1, 3.0, and this is going up to almost 5. This is how the data has been displayed. So now moving on, the categories or the groups here, the categories of the groups are the different surveys that were carried out in different time periods. So for example, the Pakistan Demographic Health Survey carried out in 1990 to 91. So if you don't know PDHS, the meaning of PDHS, you don't have to say it. You can just say the PDHS that was 1990-91, PDHS 2006-2007, PDHS 2012-2013, 2017 and 2018. So I think as an OB consultant or as an OB trainee, obstetric trainee, you must be aware of the Pakistan Demographic Health Survey, and you must know that PDHS stands for Pakistan Demographic Health Survey. So perhaps I will do a short video on Pakistan Demographic Health Survey also for you. But I would urge you to know about these basic background information and data that flows in regarding our women, their fertility, etc. So here there is a legend. The legend is something like this. Legend can be in the form of a table, or it can be just given simply as here. And here it is showing the total fertility rate. So for example, this top line is showing the total fertility rate. The orange word here is saying difference. So the difference is in orange, and it is pointing to this difference in orange of 0.7 or 0.8 or 1.0 or 0.6. And the total wanted is given in green. So it is representing this vertical bar in green, and so it means that this is the total number of pregnancies that was wanted by this women, and this is the actual fertility. So the total fertility was 3.6, but women didn't want these babies, they wanted these babies. So 2.9 is the total wanted, but some of them became pregnant even though they did not want, and so the total fertility rate was 3.6. So this is what this table is telling us, that and then we talked about grid lines. So there are no grid lines here. There's no outside line here. There's no lines going around like this. Sometimes the study researcher will put lines over here, so it is easier for you to understand. They'll put an x-axis here. They'll put a y-axis here. They'll put the numbers here so that you can understand. But here it is just given as a simple one. And it is a vertical bar chart because the numbers, the chart is shown with the rectangles going up like that. So it is known as a vertical pie chart. Supposing that this line was like this and the bars were coming out like that, then it will be known as a horizontal bar chart. So let's move on to so that bar chart that we just saw, that was a stacked bar chart because there were stacks of the total number of children the woman had, the total number of children that the woman had but was not wanted in orange, etc. So that was a stacked bar chart. Now we come to a clustered bar chart. In this clustered bar chart, you can see that there's a combination of grouped, it can be a combination, but in this, you can see there is a blue bar, there's a red bar, and there's a green bar. So there are 3 bars in each category. And there are 2 categories, women and newborns. So let's see now, let's see the title. So now let's just imagine that somebody has given you this bar chart and they say, please explain this bar chart to us. How will you respond? You will say that this bar chart is showing us the postnatal care by place of delivery. So it is showing us where was the postnatal care done by place of delivery. In other words, where was the delivery done and what was the postnatal care. So the authors have also given some explanation of the title, percentage of last births in the 2 years before the survey for which women and newborns received a postnatal check during the first 2 days after birth. So in other words, what we understand from this is that each of the bar charts is represented as a percentage. So they are all 79% of all the women in Pakistan, 19% of all the women in Pakistan. So basically we are shown a percentage. And these are showing, so there are 3 categories of patients who delivered either in the health facility or who delivered somewhere else or who delivered, and so this is the total. So this elsewhere could be in the home or maybe in the taxi or in the transport, but mostly in the homes. So if we see this and we see this, there are two bar charts actually. It's a clustered bar chart, so there are actually 2 charts, and this data is showing us that that 79, that out of these, this 100% of women who gave birth or who had postnatal care. So this is the total, 62% of women. So this cluster is representing the women, and this cluster is representing the newborns. So they are showing us if the woman had a postnatal visit, or if the newborn baby had a postnatal visit. So in other words, because this is a total, so only 62% of women had a postnatal visit within 2 days of delivery, whereas 64% of babies had a visit within 2 days of delivery at a health facility. So as you can imagine that this is, it's very similar. So we can say, yes, it is very similar that the number of women who are going for their own checkup are also going for the checkup of their babies. And this 62%, when it is dissected down, it shows that 79% of these women were delivered in a health facility. It means that more women will go for postnatal checkup if they are delivered in a health facility. But if they're delivered at home, then they will rarely go for a checkup. So if you add this and this, the number is 100%, but this is 62% of all women who actually had. So in other words, for 48% of women or 38% of women never went for a postnatal checkup. And similarly here. So I hope you understood that. Let's move on. Now this is a normalized bar chart. In this normalized bar chart, what we are seeing is that if you add these up, then it comes up to 100. If you add this up, this comes up to 100. And if you add this up, it comes up to 100. And that is why the top part is all the same. Okay, so let's read the title first. So that is the first thing that you see, that this is a normalized chart because all the figures are the same, 100%. Now let's see what is the title. So this chart is telling us, it's a bar chart. It's a normalized bar chart, and it is telling us that it is showing us that what kind of household drinking water do people have by their residence. Okay, so the residence, the categories are urban and rural. There are two categories, urban and rural. So obviously when you combine these two, then you get the total, which is the total. So the red bar says unimproved source. You would have to have more information from the text to know what is unimproved source. The light blue says bottled water. The orange part says filtration plant. The light blue here says protected well or spring. Then the slightly darker blue says tube well or borehole. And the slightly darker one says public tap or standpipe. And then there's a dark blue one, she's saying piped water into dwelling, yard or plot or neighbor's yard. So the first thing you deduce from this legend, which has been provided here to demonstrate the results which are being given here, is that only 24% of people in Pakistan in the 2020 survey have drinking water which comes out of their pipe, which comes into their own house or which comes into the neighbor's house. So out of the 24%, we see that in the urban area, it is 36%, but in the rural area, it is like half. So it's slightly more than half, but it's almost half. So only half the number of people who are living in a rural setup have piped water into their yard, into their house, or into the neighbor's yard, whereas 36% of people who are living in the urban setting have water which is coming through the pipe into their homes. And similarly, then you can go on and say that 5% have public tap and 65% have tube wells. So obviously in the rural area, more people are drawing water from the tube wells as compared to the urban area. And then filtration plant, less people have filtration plants located in the rural area as compared to 7% in the urban area. Bottled water is rarely used in the rural area as compared to the urban areas, and unimproved sources are more in the rural areas as compared to the so overall this is telling us that this is the sources of water supply that people are having in the urban as well as in the sector. Okay, let's move on to the meta-analysis and to the forest plot. So before understanding the forest plot, let's just go quickly over the meta-analysis. What exactly is a meta-analysis? So what is the meaning of meta-analysis? This is a research methodology. So for example, that in my earlier videos, I have talked about different types of methodology that we use for conducting research. We can have randomized control study, we can have observational studies, we can have different ways to describe studies, but these are mostly on individual patients or they are on communities. But what is the difference between meta-analysis as compared to those studies? So this is a research methodology that involves a systematic review and statistical analysis of data from multiple studies. This is the main difference, that your data set is actually multiple studies, not individuals, not communities. In the context of OBGYN, meta-analysis is used to evaluate the results of multiple studies on a particular intervention or a treatment or a risk factor, with the goal of summarizing the overall evidence on that topic. So researchers sometimes do this I won't say sometimes, but very often they do meta-analysis to pool the data from different studies, but they have to use very strict criteria to pool when they are pooling the data so that they can have equivalent studies. So this is an example of a meta-analysis on an obstetric topic. This is not something that has been published. This is just an example. And so please don't think that this is any of the data that is, or any of the findings that are shown here have any significance to any patient or to anybody. It's a hypothetical example. And it just shows you what is the methodology. So here, for example, the title is Meta-Analysis of the Effect of Maternal Age on Pregnancy Outcomes. And the objective is to assess the impact of maternal age on various pregnancy outcomes. And the methods are that, and here, so now the way that you collect the data is to do a literature search. So the authors decided that they will do a comprehensive search of electronic databases, for example, PubMed, Embase, Cochrane Review, to identify relevant studies on this topic published between 2000 and 2021. And the search terms included maternal age, pregnancy outcome, preterm birth, low birth weight, and gestational diabetes. So they had 4 categories that they were looking at when they were finding the studies to include them in their meta-analysis. So they wanted to know about maternal age, so they only took those studies where there was maternal age and there was the authors had mentioned pregnancy outcome in the form of preterm birth or low birth weight or gestational diabetes. So statistical analysis, then they did different kinds of statistical analysis on this data. And the results, they showed that the meta-analysis included a total of 20 studies with a combined sample of 100,000 pregnant women. So this is the reason why people do meta-analysis. They do these meta-analysis because the meta-analysis then allows them to get these huge numbers, and then they feel that the results of these huge numbers has more relevance as compared to smaller studies with small numbers. And so there was so in conclusion, the meta-analysis provides evidence that advanced maternal age is associated with increased risk. It's something to be expected. But this is a hypothetical example. This is not actually an actual study, but I just showed it to you just to demonstrate to you how the study is conducted. Now we come to the forest plot. Now this forest plot is actually taken from a study, not the study that I just mentioned, but just a study. But I have eliminated the title and the study, the names of the authors in the study to make this anonymous and to make sure that we don't have any copyright problems. Okay, now so somebody shows you, so this is a forest plot. Now if someone shows you a forest plot, then how are you going to explain the forest plot to the person? So first of all, of course, you have to have a title, because the title will tell you exactly what this study is all about, what kind of intervention, what kind of risk factors, what kind of, what is it all about. Here, I have not given you the title because I have obliterated the title here for the sake of keeping the plot anonymous. But if you get one in another setting, then you must first read the title. So in this particular forest plot, this is showing the results of a meta-analysis, and the results in this particular study, there has been an intervention and there has been a control group. Now, if you see, the first important thing that you have to note is that there is a vertical line here. This line is centered and it is marked as 1.0 on this horizontal line. So this horizontal line is representing a logarithmic scale. So there's 1, there's 2, there's 5.0, and if you go in this on the left hand side, there's 0.5 and 0.2. So this is then demonstrating the effect size, the effect of the study. So according to this vertical line, this line is indicating the line of difference. So anything which is on the right side of the line is showing a difference, and anything which is on the left side of the line is showing no difference. So in other words, the left side of the line is showing a negative impact and the right side of the line is showing a positive impact. So if you go to the top of the, so this whole thing is arranged in groups, and there are some columns in the group, rows and columns. In the row, you find that the first item on the row is study or subgroup. So all these are studies that were conducted in different years. The earliest being 1979 and the latest being 1989. So they're always arranged in a chronological order, top to bottom or bottom to top. And in this, the second item on this row is treatment. And this is showing the small n, or the actual number of patients who had the treatment, and the big N, the total population from which these patients were taken. So there were 15 patients who had the treatment out of a population of 131. And then in the same study, there was a control group of 22 from a population of 137. Okay. Now this is, I've just explained this a little bit to you, but I will explain to you in some detail again. And this is showing the risk ratio, 95% confidence interval. So this is the risk ratio, and this is the 95% confidence interval. Now we come to the columns. So this first column is showing us a study or the subgroup, the treatment group, the control group, the actual diagrammatic representation of the risk ratio and the confidence interval, and showing diagrammatically what is the impact which we see in terms of intervention and the results. And this is showing actual risk ratio as well as the confidence interval. At the bottom row is showing a subtotal of 95%. So in this subtotal, the total number of patients who were involved in the study has been shown as 1,813. And the total number of patients who were involved in the control group, 1,814. And the risk ratio was 0.77. And here, the point estimate is represented as a diamond. So this is a summary of the entire table. So in this vertical line, as I said before, that this vertical line is shown, and this vertical line is intersected by some horizontal lines. So each point here is the point estimate, which is the risk ratio, and here this is the confidence interval. The horizontal lines that are extending beyond this is the confidence interval. So basically, if you go down, you see that overall, in this intervention, you show that this intervention did not really have a very positive impact on the outcome of the patient, and most of the data is lying on the left side. And also the summary diamond is also showing that the data and the point estimates are lying on the left side, indicating that in this meta-analysis that we did, or the authors did, and in which they include 1, 2, 3, 4, 5, 6, 7, 8. 8 studies were included, a total population of 1,813 patients in the treatment group, 1,814 patients in the control group. It indicated that there was no result or no positive effect of the treatment, and the majority of point estimates of risk ratios were lying on the left side of the table. This is another table, a very similar table, but there's a slight difference. That is why I put this in. Again, this is showing, so if somebody says to you that, can you please interpret this forest plot, then the first thing you have to do is you have to read the title, which I have actually obliterated here because this is for the sake of anonymity and the risk of copyright infringement. I have obliterated that, but this title will tell you exactly what kind of data is being used in this, or what kind of studies are being used in this meta-analysis, and why this meta-analysis has been done. And so the studies that have been included are these. The risk ratio is here. The percentage weight. So here the percentage weight is being given, and usually it is as a percentage. And here again you have the vertical line, which is showing the vertical line of difference. And again here you have the horizontal line, which is showing the logarithmic scale of central point is 1, and then on the right hand side is 1.5, and on the left hand side is 0.5. But here you have another dotted line, and this dotted line is showing that this data is actually lying on the left side, and so they have put a dotted line here to show that that majority of the results are negative, and just a few of them are showing even some slight positivity, even though all of them are on the left side of this line of no difference. So in case you come across this dotted line, don't get confused. This is just an additional line which the authors have drawn because everything is lying on the left-hand side. And as you can see that there is a diamond here and these are squares here. And this diamond is showing the overall effect, the summarization or the overall effect, and these are showing these are the point estimates of the particular studies. So for example, in 1996, this study was done. This is a point estimate for this study. 0.71, and these are the risk ratio, and these are all the point estimates. Now, if you see carefully, you will see that there is a difference in the size of these squares. And the difference in the size of these squares depends upon the point estimates and the risk ratios. So for example, if it is 0.75, it is a smaller square, but it is a 0.93, it's a slightly larger square. I hope you get that. I did not explain this to you in the previous slide, but in every forest plot you will see that these squares or dots or circles or whatever is being used, mostly it is squares, but sometimes even circles are used. You'll find that these will be different sizes, and these different sizes are because of the difference in the point estimates, the size of the point estimates, and the weightage of this risk ratio. So for example, here the percentage weightage of this point estimate is 12.3, so it's a slightly bigger one. Here it's 3.9, so it is very tiny. Here it's 2.7, so it's very tiny. 4.5, so it's slightly bigger. So these are the weightage which is being provided on the basis of the risk ratios, that these are the sizes of the squares. Then there is also a footnote here, total interventions, for example, total intervention events, test for heterogeneity. There are different kinds of things which you don't have to explain, but you can say that this is a legend for this particular forest plot, which you can explain if you have more information. So with this, we come to the end of the video. If you like the video, then please press the like button, subscribe, share, comment, and press on the bell icon. Thank you and goodbye.